All right. I am going to show you just one other way of being able to kind of think about this, of dealing with this. All right. And some students like this. It gives them a little bit of organization. Some students think that, well, that means that I do some extra work. Some people are okay with that. Some people are not. Okay. So what I want to show you here is this is all one question, right? We have 1 gram of hydrogen gas, period. Okay. This method does not work in the earlier questions where one question said you have 42 grams of this. In this question, you have this many moles, and if it's changing every time, this is not very helpful. You can only use this for one situation at a time. Okay? So some people like this. So they put their equation down. So they go 2H2 plus O2 turns into 2H2O. All right? On the top, they're going to write down the molar mass. Okay, so they're just going to find the molar mass of everything. You figured you're going to need that anyway. So the molar mass of hydrogen, I'm going to look up hydrogen. Hydrogen is 1.008. So I go 1.008. I'm going to multiply that by 2 because there's 2 hydrogens. The molar mass of hydrogen is 2.016 grams of hydrogen in 1 mole of hydrogen. I'm going to do the same thing for oxygen, right? I look up oxygen. Oxygen is 15.99999, so I go 15.999 and multiply that by 2, and I get 31.998. Okay? So that would be 31.998 grams of O2 per 1 mole of O2. And then they do the same thing for the water, right? So for the water, we go 1.008. I got 2 of those, and then we add on the 15.999, and we get approximately 18, okay? Again, my calculator's doing a little bit of rounding here. Somebody put it on the 3-digit mode, but it's going to be close enough. Okay, for our purposes, this should be close enough that it shouldn't be an issue. All right. So the first thing we did is we just went ahead and we found each molar mass. We figured, you know what, we probably may end up using those anyway, so I'm going to go ahead and write those all out. Okay. In the next step, we can write down moles. We'll go here. This is how many moles we actually have. And then in the bottom, we put grams. And this is how many grams we actually have. Now, in the original question, I know I have 1 gram of hydrogen gas. So I'm going to start with this. I'm going to say, well, I have 1 gram of hydrogen. Okay? Now, what I'm going to do is I'm just going to fill out this chart. Okay? I'm going to start by turning grams into moles. Then by using the mole ratios, I should be able to find the moles of the other 2. And then I should be able to find the grams of the other 2. Right? And so this just gives me a way of organizing things and kind of giving me a structure or process. Again, you don't have to do this. You can use the other method that I was showing you before and just do it one by one. That's also fine. Okay, but I'm going to go ahead and show this to you just because some people like this kind of organization. All right, so I'm going to be turning, I have 1 gram of hydrogen. I want to turn that into moles of hydrogen. And so I'm going to start with 1 gram hydrogen. I'm going to multiply that by my fraction. The fraction that I'm going to use is this one that will turn me from grams of hydrogen to moles of hydrogen. I do want my grams to cancel out, so I'm going to put the 2.016 grams of hydrogen on the bottom. I'm going to put the 1 mole of hydrogen on the top. From there, I can see the grams of hydrogen will cancel out. And I'm going to go 1 divided by 2.016. And I get 0.496. All right? So this was 0.496. So that is 0.496 moles of H2. Now, to go from here to here, we can use our mole ratios, right? So I know that I need 2 moles of H2 for 1 mole of O2. Okay, so I'm going to now multiply this. So I'm going to take the same number as before. I'm going to take that 0.496 moles of H2. I'm going to use my conversion factor, 2 moles of H2, 1 mole of O2, so 1 mole of O2 and 2 moles of H2. Again, we can get the moles of H2 to cancel out, and so we'd have 0.496 times 1 divided by 2, and so I get 0.248 moles of O2. And then you'll notice that the moles of H2O is the same as the moles of H2, so I could use a ratio if I wanted. I could do the same thing, or I could just say, well, I know that I have the same number of moles of these two, so if it's 0.496 moles of H2, it's going to be 0.496 moles of H2O. So now I have the moles of everything. So to finish, I just need to go back from moles to grams, and then I should be able to finish up my table. I should be able to answer the rest of the question. And so therefore, I can take 0.248 moles of O2, I'm going to use my molar mass that I wrote down before. I do want the moles of O2 to cancel out, so it's on the bottom there. So 31.998 grams of O2 is 1 mole of O2. So the moles of O2 cancels out. So it'll be 0.248 times 31.998. And I get, that's the O2 here. So that is 7.94 grams of O2. And then I can do the H2O. Okay, so again, I'll go 0.496 moles of H2O times 18 grams of H2O divided by 1 mole of H2O. Moles are going to cancel out. So 0.496 times that 18, which I know wasn't exactly 18, but we'll work with it, 8.928. So I'm going to go 8.93 grams of H2O. All right? Now, I didn't even look at the question. The question is asking, how many grams of oxygen do you need? Well, I got that answer now. If I have 1 gram of H2, I need 7.94 grams of O2. The last question is, how many grams of water will you need? Well, I just got 8.93 grams of water. Will be, sorry, not what you need, but what will you get as a result. Okay? So, as you can see, the table helped. It actually got me both of the answers that I was looking for. It does give a little bit of structure organization. If you don't like that, because some people feel like the structure is a little more chaotic. They like the idea of just doing one thing at a time. If that's the case, that's fine. Do that. If you do choose to use the table, recognize that usually the point of the table is to get to this middle, to get to the moles. Once you get to the moles, you can then solve for grams. All right, that's it. Hopefully that was helpful. We'll see you next time.